How does a wave carry energy from place to place? It all starts with a disturbance in the wave's medium. The medium is the stuff the wave travels through. For ocean waves, the medium is the water. For waves produced by an earthquake, the medium is the earth. For sound waves, usually the medium is air. For waves on a string, the medium is the string itself. When you make waves on a string, you shake one end up and down. The wave travels away from you through the string. Notice that the wave is just a traveling disturbance. The string only moves up and down. It doesn't travel with the pulse. This is true for all waves. Ocean waves don't move water from one place to another, just the energy contained in the disturbances. When you hear the sound of a lecturer, the only molecules of air that exert pressure on your eardrum are the molecules that were already near it. You can calculate the speed of a wave by multiplying the wavelength by the frequency. The speed of a wave depends on the medium it travels through and the conditions of the medium. The speed of sound in air depends on the temperature of the air and ranges from about 330 meters per second to 350 meters per second. When the sound travels through water, it moves much faster. Whatever medium a wave travels through, its speed, wavelength, and frequency are related. If the wavelength is 1 meter and 1 wavelength per second passes the pole, the speed of the wave is 1 meters per second. If the wavelength were 3 meters and 2 wavelengths go by each second, then the speed is 6 meters per second. The relationship between speed, wavelength, and frequency is wave speed equals wavelength times frequency. Since the speed of a wave is constant in a given medium, the wavelength and frequency have an inverse relationship. In other words, in sound waves, as the frequency goes up, the wavelength goes down. Let's try an example problem. All right, let's read the problem first. Radio station broadcasts at a frequency of 99.5 megahertz. What is the wavelength of the radio waves? The speed of radio waves is 300 million meters per second, which, by the way, is the speed of light. All right, well, we're looking for the wavelength, and we know the frequency, so that's frequency, and we know down here is the speed, okay, and the relationship we have between those is that speed equals wavelength times frequency. To solve for the wavelength, let's divide both sides by frequency, and we'll get that wavelength is speed over frequency. Now there's an issue here, which is that megahertz is the unit given for frequency. We can't do anything with that because we need it to be in hertz. So let's make a conversion. 99.5 megahertz. And if you'll recall from the previous videos, a megahertz is a million hertz. So 1 megahertz is 10 to the 6 hertz. Okay, and if we multiply those two together, we're going to get 9.95 times 10 to the 7 hertz. All right, now we have something we can work with. So let's take our equation down here and substitute in for velocity and frequency. So the speed, again, is 300 million meters per second. Let's write that as 3 times 10 to the 8 meters per second. And we've got 9.95 times 10 to the 7 hertz. Okay. And let's put that in the calculator. All right, the calculator is telling me that that's going to be 3.02 meters. And now we know the wavelength of the radio waves.